Good morning. Hello. How's it going? Or afternoon, I guess, if you're watching this at a different time. Just wanted to pop in, say hello. This is Notes 1.03. Again, if you do not have the packet available to you, you might want to pause the video, write down the bold words, try to draw out the pictures, and we're going to get started. So I'm going to hide myself for a minute. Sure I am. There we are. So the angle addition postulate states the sum of two smaller angles adds to a whole, or adds to the whole angle. Right? So looking at the diagram, if C is in the interior of angle ABD, so the largest angle we're seeing is angle ABD. That means this angle, represented by 4x plus 2, which is ABC, and this angle, CBD, add up to make the whole. So the measure of the whole angle, the largest one, equals the measure of angle ABC added to the measure of angle CBD. So again, B is that vertex, it's in the middle, it's where all the rays meet. So moving down to exercise 1, if we know the measure of the whole angle is 100, so both of those angles add to 100 degrees, set up an equation to find the value of x and the measure of ABC and CBD. So our equation, we're going to replace ABD there with 100. So 100 degrees equals, sorry, I'm in school. They're changing periods. Equals the sum of these two angles. So angle ABC is represented by 4x plus 2. Angle CBD is represented by 3x minus 7. Combining like terms, 100 equals 7x minus 5, because 2 minus 7 more is negative 5. Add 5 to both sides. 105 equals 7x. X will then be 15 if we do that division. So again, 105 divided by 7 does give us 15. And that's just the value of x. We also were asked to go back in and find ABC and CBD. So the measure of angle ABC equals 4 times 15 plus 2 is going to be 62 degrees. And the measure of that opposite angle, CBD, equals 3 times 15 is going to be 45. Subtract 7 is 38 degrees. And just to double check, 62 added to 38 does give us 100, which is what we set it equal to based on the measure they gave us there. So that's exercise 1. We add the pieces up to equal 100 degrees in that case. An angle bisector is a ray that divides an angle into two congruent angles. And again, I do like to use a lot of symbols for the words we have. So when we have a bisector, okay, what that's going to do is here, if we have this large angle, RQP, it says that QS, this segment coming out from the middle, bisects the large angle RQP. So with that angle bisector, it's going to tell us that this opening, RQS, here, I'm going to do a little double arc mark there, and this opening, SQP, are equal. So whatever this one is, this would be the same measure. So they gave us a couple expressions, however, to represent each piece. So RQS is represented by 2x plus 10, and SQP is represented by 3x minus 18. So again, with an angle bisector, you're going to have one angle equal to another angle. So we're going to make the substitution that 2x plus 10 equals 3x minus 18. And to solve for x, we can subtract our 2x from both sides, add the 18 from both sides, x's will cancel, 28 equals x, 18's will cancel. So from there, we know x to be 18. There, it goes on to ask to find the measure of SQR. So SQR is represented by that 2x plus 10. So angle SQR is twice 28. Add 10 is going to be 56 plus 10 more. It's going to be 66 degrees. Okay. So this angle is 66. Guess what? With a bisector, 3x minus 18 would also be 66 if we were needing that one as well. Okay. Moving on with the idea of some angle bisectors here. So given the big triangle ACE, so we have triangle ACE. Okay. We're told that three segments, CF as a segment is an angle bisector. So that's going to cut these two angles, 3 and 4, into equal pieces. It also goes on to say EB, E to B, is an angle bisector. It's a really bad trace job there. Let's try that again. EB. And the last one, AD, are all angle bisectors. So angle bisectors tell us that the angles are congruent, or angles are equal there. So angle 3 would be congruent to angle 4. Angle 2 would be equal to angle 1, that number right next door to it. I'm going to skip part D down here. So if you were kind of writing everything out ahead of time, letter D, we are going to skip. I'll shove this up. Letter C. We're going to use the picture to the right because, again, since this is exercise 3, notice that all of these pieces kind of fall under it. So whatever they told us up here, we're going to use that same information down here. Sorry about the bells. So angle CAE is 50. So it's from C to A to E is 50. That means that whole angle measured at A is 50 degrees. Well, we know we had an angle bisector, so that makes each of these half of 50. So we have 25 degrees there, 25 degrees down here. Next, they give us the angle ACE is 80. So angle A up to C to E. So notice C is the middle letter. That angle at C is going to be 80 degrees. So that is going to get split into two equal pieces, 40 and 40. Then they go on to say, what is the measure of angle 5? Well, 5 is way over here. I have no idea what that measure is, unless we go back to a rule. So remember, any triangle, the sum of these three angles, anybody remembers? It's always 180 degrees, okay? So we have that this big angle is 50, this big angle is 80. So if I take 180 minus 80 minus the 50, I'm left with 50 degrees. So this whole angle at E is going to be 50 degrees. And we knew we had that angle bisector EB coming through there. So what that tells me is that the measure of angle 5 is going to be 25 degrees because each of these have to be equal. And we know 25 and 25 would add to 50. So we essentially divided there by 2. So those are some angle rules. Again, Here we added the angles to equal 100 because that was the measure they gave us. In this example, when you have an angle bisector, the items are always equal to one another. And last, more angle bisectors, we did some division there, cutting the angles in half since they were each equal to each other. Okay, some more vocabulary. This first word here is collinear. Okay, so the word collinear is going to stand for, we're going to talk about points here that share a line. So this is a vocab word that might show up in different questions, but collinear, like co-captains, co-presidents, share the responsibilities for a team or a class. Co is another word for sharing. And then you have the word linear. So collinear, points that share a line. Here's a little sketch we can draw to kind of make that word come to life, seeing its geometry. Points A, B, C, and D that are collinear on line M. So remember, we can name a line with a lowercase letter. So we're going to draw a line here with double arrows because lines go infinitely in both directions. I'm going to put a little cursive M there. But they're saying points A, B, C, and D are along that line. So they are all sharing line M. However, point X marks the spot, right, is non-collinear. So it's not on line M. So point X is kind of floating somewhere else. So that's just a little diagram to kind of remember some of our notation here. Midpoint is a point in the middle, or a point that breaks a line. Let's say breaks a segment, because lines are infinite. We can't really cut that in half, but breaks a segment into two equal segments. So remember, a segment has a start point, let's say like A, and an end point C. So we could have segment AC there along that line M. So here they're asking us to draw a picture. So points D, E, and F, and again, those are capital letters on purpose. So points D, E, and F are collinear points, and E is a midpoint. So we're going to draw a segment starting from D to F so that E is in the middle. So I'm going to kind of approximate it right here. So what we know is that this part from D to E, if I were to measure it with a ruler, and this part, E to F, should be equal to each other. And write a congruent statement would be that segment DE, not BE, Miss Locke, DE, it is congruent to EF. So that's the congruent statement. I should have had it on the line there, but I didn't want to run into my other word. Okay, so those segments are congruent. So if I were to find a ruler, I don't think I have any ruler tools here, and measure from D to E, maybe that's 6 feet of distance, right? If we're trying to socially distant. And then we have 6 more feet. We break something into 2 parts. Lastly is segment addition here as vocabulary for today. So quick notes today. Segment addition is very going to be similar to angle addition. We're going to add 2 things to make a bigger thing. Well, we were talking about angles earlier. Now we're going to talk about segments. So segment addition is going to say if point B is between A and C, then you're going to add those parts up to equal the whole. So if point B is between points A and C, so we have A, B, and C. Now B sometimes might be the middle, okay, about here. You can see that little dash, but it doesn't necessarily have to be. But if person A and person B are only 2 feet away from each other, and person B all the way down to person C is 10 feet away from each other, then person A to person C would be 12 feet apart. Okay, so here you're going to add the two little parts up to equal the whole. So moving to an algebraic example like number 4, it reads, in the diagram below, segment DEF is shown. Since all three letters are shown, they are collinear. If DE is represented by twice the value of x, 3 times x plus 2, and EF is represented by x plus 5, and D to F is 23. Now, architects use this kind of scale factor essentially when they're drawing pictures. Okay, so imagine a floor plan. If you guys have taken a CAD computer drawing class, say that's done on graph paper, right? And they tell you one box equals 10 feet by 10 feet. Okay, so if you span 4 boxes, you're taking up 40 feet theoretically. So that's where the segment addition kind of translates into a career or something out in the real world. But here they're telling you from point D to point F is a total of 23 feet. So what we're going to do is we're going to add up DE plus EF to equal out to that whole measure 23. So D to E is represented by 3x plus 2. Add that to x plus 5, and we're going to get 23. So combining like terms, we have 4x plus 7 equals 23. Subtract your 7 over. 4x equals 16. X in this case is 4. Okay, so that's exercise 4. Exercise 5 is a picture, and they give us some information. Given AD, so A to D is a whole long segment going straight. The whole measure from A all the way down to D. So I'm doing this like funky bracket to kind of tell me that from point A to point D is a whole measure of 24. B to C, just this inside piece, is 12. Now notice I'm using different colors to kind of help with the measurements. That might be a strategy to help you throughout. They also give us that AB and CD are equal. So if this little measure and this little measure are equal. Now I'm putting these little dash marks or tick marks, they call them, on there to show that this one and this one are of the same measure. We're going to put an X in there. We don't know its measure, but we know that they're equal to each other. Well, these three pieces, A to B, B to C, and C to D, all add to 24. So we're going to write an equation. X plus 12 plus X equals 24. Combining like terms, we have 2x plus 12 equals 24. Sorry for my handwriting. My Chromebook is kind of skipping out on me. Subtract our 12 over, we get 2x equals 12, and we know x to be 6. Okay. So replacing each of those x's, we know is now 6 here, and this one equals 6. Let's see what they're asking for. So A to B will just be a measure of 6 feet. B all the way down to D, well, B to C is 12, plus 6 more is going to be 18 feet. Okay. So that's it for notes. So with those as notes, we did a few examples along the way. Here is graded classwork 1.03. Most of your classworks have been graded, but with this one, I'm probably going to count it out of more points than just 10. So I'd really like you to be trying number 1. Make sure you're looking for your alternate interior angles. So there's like a Z here. So if 60 degrees is there, well, 5 would be 60, 1 would be 60. Please mark up your diagrams. Put numbers into the picture because that's going to help you find something else later on. Okay. Number 2, I can help you with a diagram. So RE bisects angle TRS. So this is an angle bisector example, just like number 2 on the first notes page there. So angle TRS is the large angle. RE is the bisector, so it's coming out in the middle. So what that tells me is this part of the angle and this part of the angle are the same measure. So you're going to set the angles equal to help you out there. Number 3, these little arrows show you that the lines are parallel. So what we can do is assume the alternate interior angles here. So if you need help remembering alternate interior angles, okay, I like to draw in the Z, and the angles in the Z are equal to each other. So look back at your notes 102 if you need help with that. Number 4, I'm going to have you skip. 5 should be pretty self-explanatory. A diagram for number 6 I can help you with quickly is going to be a straight line. So points A, B, and C are collinear. Point B is in between A and C. So if A is here, B is somewhere in there. It might not be in the middle. We don't know that part. And C would be over here. Okay. For this diagram, notice the whole measure is what's denoted down here as 18 from P all the way down to S. And then each of these are represented by 2x minus 6. From Q to R is 1 unit, and the last one is the x minus 4. So that's your segment addition, where you're going to add up the little pieces to equal out to your 18. That should be it for your classwork. Good luck with everything. Thank you very much. Email me with any questions.